Oh, welcome to video 3. Last class we were doing a couple of we are still in the fundamentals. Okay, we are finishing up the fundamentals this week. Fundamentals. Okay, fundamentals. The last one. Okay, so we are looking at a couple of things today. Uh, the first one I want to look at is what is density. Okay, density of a substance is generally we talk about the thickness of some substance. Okay, thickness. But density is nothing but mass over volume. Okay, so there is a formula for this. So whenever we look at any of this, we have to look at how many parameters it comes with. Okay, density is the first parameter, mass is the second parameter, and volume is the third parameter. So density is equal to mass over volume, and always formula and units are connected. Formula and units are always connected. So the formula, the units for mass is grams, and volume can be written as milliliters. So the density unit for density is can be represented as gram per minute, or it can be represented as kilogram per liter. Okay, so it can be represented by any way. So, but you can interchange this formula. Okay, so I can change this as if I have to find the mass is equal to, I can move the volume to this side and write density mass is equal to density times volume. Or if I have to find volume, I can interchange and write volume is equal to mass over density. So let's look at some of the problems to understand how this works. Okay. So let's say that there is a substance and the mass of that substance is 10 grams. It is given 10 grams. And then the volume is 2 milliliters. So what the formula, you just have to simply use the formula, right? Density is equal to mass over volume. So it should be 10 grams or 2 ml. It should be 5 gram per ml. So that should be the density of the substance. So if the question is asking, right, so you have a volumetric cylinder, and first initially you have some water. So the amount of water that you have initially is 23.9 ml. And then inside this, I threw a rock. And then the water rises. The new volume is 25.7 ml. Now, from that, the mass of this rock is 10.5 gram. So, if I have to find the density of the rock, now all the information are given here once again. The mass is given, but the rock, when we added, it displaced a certain number, so certain amount of volume. That is the amount that is needed. So basically what we have to do is density is equal to mass, that is 10.5, divided by this volume is nothing but the volume and the amount that is displaced. So that is 25.7 minus 23.9 to get the final answer. So this is a very simple way to calculate a density of a substance by putting inside water. That's called displacement method. The next one we are going to learn is about what is a solute, what is a solvent, what is a solution? A solute is a substance that is added into solvent to make a solution. So we take sugar, you add it to water to make a sugar solute. Or you take salt and you add into water and you make salt solute. So a solute, you can remember that the amount that is less is added to a lot to make a solution. So you can see that you can remember just by 1, 2, 3, 4, 5, 6 letters compared to 1, 2, 3, 4, 5, 6, 7 letters. So less by more. Okay. Not a lot, let's say. So let's say, okay, it's accurate. So you add anything, you take some water, if you add sugar into it, this sugar is called as the solute, and this water is called as a solvent, and finally you end up with a sugar solute. In this process, how much sugar you can add in a certain amount of volume. So let's say we have 100 ml of water. We try to add first scoop. It goes in. And then you try to add second scoop. It goes in. You add third scoop. It goes in. You add fourth scoop. It goes in. But how many you can add? So till you can, the sugar goes in, it is called as unsaturated solution. Unsaturated solution. Once there is a time when you add more and more, then you see that the sugar is getting deposited at the bottom. Then this happens. This is called as supersaturated solution. It's already saturated. All the water molecules are already connected with the enough of water, enough of sugar is already there. And then it started depositing at the bottom. Then it's become supersaturated. So this is very important. So we have so many vocabulary words here. We have the first one is solute, solvent, solution. Now you have unsaturated, you have supersaturated. If you perfectly made a solution without this deposition, without this thing at the bottom, is called a saturated solution. Yeah, that's a little bit difficult to me. Okay? Very difficult. Now we have what is called as solubility curves, that we are going to learn later. Okay, solubility is a very difficult topic to see, because how much salt can go inside a certain amount of solvent is called a solubility curve. It might depend on temperature. If you increase temperature, more salt will go inside. If you cool, more salt will come outside. Okay, so we are going to learn that further later. The last one we are going to look at today is called as the dimensional analysis. Very, very important. The dimensional analysis is a method to solve problems. So let's say I have 1 foot. 1 foot can be written as 12 inches. This is the conversion. Or I can write 12 inches as 1. Similarly, 1 gallon is 4 quarts. Or I can write 4 quarts as 1 gallon. So how we use dimensional analysis? Using dimensions is very important for solving all the problems of chemistry. So let's take a question. How many feet of are there, feet are there in 55 meters? To solve this, we always take what is the only number given here. The only number given here is 55 meters. Now, the final answer, what we want is feet. How many feet? So write feet. So somehow the meters has to become feet. So just draw at least 3 of the division. We call them fence. Okay. So meters has to convert into feet. So we write 1,000 meters is 1 kilometer. I can either write 1 kilometer over 1,000 meter or 1,000 meter over 1 kilometer. I'm writing 1,000 meter at the bottom because then only I can cancel this meters and meters. Okay. So that is the reason I'm writing this. Very important. So to cancel kilometer, I write 1.61 kilometer is equal to 1 mile. So then only I can cancel the kilometer and kilometer. And now write 1 mile is 5280 feet. How do I know all these things? Because you have to either memorize them or they will be given in the exam. Okay. So you don't have to memorize all of them. Okay. And mostly for chemistry, it will be pertinent only to chemistry. Nobody is going to ask you how many miles you are running inside the lab anyway. Okay. So what we are going to do is we are going to cancel kilometer, kilometer, mile, mile. And then you see that we have left with only one unit here, feet, and you need only answer in feet. Now I'm going to take 55 times 1 times 1 times 5280 divided by 1,000 times 1.61 times 1. And I'm going to write the answer as 180 feet. It's very simple. Now let's look at one more example. How many seconds are there in 3.9 days? If there is a question, so only number given is 3.9 days. I have to find how many seconds. So I'm going to write seconds. Roughly write 3. You might use 3 fences or you might not use 3 fences. You might write these, might need 4 also. But mostly nobody is going to go for 6 fences or something. Okay. So just put a 1 in below because there is nothing there. So days, to cancel day, 1 day is 24 hours. 1 hour is 60 minutes. 1 minute is 60 seconds. So look at how I wrote. I wrote in such a manner that days and days are cancelled, hour and hour and cancelled, minute and minute are cancelled, and I get the answer as seconds. So basically I have multiplied 3.9 times 24 times 60 into 60 divided by 1 times 1 times 1 times 1 will get my answer. The units are very, very important because if you don't write the units, then you will end up with a lot of problem here cancelling. Without cancelling, you will end up with a different units here. Either you'll end up with a different unit, or if you do step by step without using dimension analysis, you will end up with a different answer. So learning dimension analysis is very important to what? To avoid mistakes. So this finish up the entire chemistry fundamentals of unit 1. One is over. Go to atomic structure. Thank you.